Hi everybody, in this video we are going to discuss about EIGRP routing protocol and also we are going to configure the EIGRP in packet tracer. So EIGRP stands for Enhanced Interior Gateway Routing Protocol. So if you see the features and characteristics of EIGRP, EIGRP is a Cisco proprietary routing protocol developed by Cisco itself, and it is completely based on the IGRP routing protocol, or we can say it is an extension of IGRP or enhanced version of IGRP. EIGRP was released in the year of 1994. It is a hybrid routing protocol. That means it is having the characteristics of both the distance vector routing protocol and link state routing protocols. If you see some of the important characteristics here, faster convergent time. So that means EIGRP is going to have a very faster convergence. It can quickly learn the networks available in a topology diagram. Superior handling of routing loops. So it can handle the routing loops. So you might have studied about these routing loops. That means two routers continuously forwarding the packets between itself. So routing loops can be very effectively handled by using the EIGRP, and it is having the improved scalability. That means if you are increasing the number of routers, it will support very effectively, it will support that. And also EIGRP routing protocol is using the dual DUAL, that means diffusing update algorithm, to select the best path. EIGRP, it uses the RTP, reliable transport protocol, to communicate between the neighbors, and also EIGRP is using the multicast concept. That means class D IP address. So multicast IP addresses for routing updates. EIGRP supports both IPv4, IPv6, and also there are so many other protocols in the network layer like AppleTalk, IPX. So it can support everything. It includes subnet mask information in the routing updates. So the subnet mask information in routing updates means whenever if you are using a classless IP address, that means whenever you are having a subnetting, when you have done subnetting, so with the subnet mask, so it will include the subnet mask information in the routing updates. Supports route summarization and discontiguous network. So here discontiguous network means is a network in which the packets sent between at least one subnet must pass through the subnets of different network. So in simple terms, a network is considered as a contiguous network when a host of the network can access any part of the same network without going outside the network. But in a discontiguous network means it will go outside the network and the other part of the network will be accessed. So very effectively, that means the discontiguous networks, it can be handled here by using the EIGRP, and also EIGRP is supporting the VLSM, variable length subnet mask, that is CIDR, and it is having a very effective load balancing system, and then supports trigger updates. So these are all the features, the features and characteristics of EIGRP routing protocol. Now we are going to use this topology diagram. We are going to configure this topology in packet tracer, and we are going to enable the EIGRP routing protocol for routing. So if you see the basic things here, how many networks available in this topology diagram means, so this is one, this is the first network, second network, third network, fourth network, and fifth network. So totally there are 5 different networks available in this topology diagram. So we are going to configure this in the packet tracer, and we are going to enable the EIGRP protocol in all the routers. So this is the topology diagram in packet tracer. So let us configure EIGRP routing protocol in this topology. Now, so let us go for the number of networks. So this is 1, 2, 3, 4 and 5. So totally there are 5 networks available in this case. Now So first thing, we have to go for the IP address planning. Now the first network, I am going to take this as a 10 network, 10.0.0 network. The second network, so let us consider this as the 20 network. 30 network, so let it be, this one is the 30 network, and here let it be the 40 network, 40, then the last one, let it be the 50 network. So totally there are 5 networks available here. So this is our IP address plan. Now, so the next step is we have to assign the IP address for the devices. So let me go to PC 0. So here I am going to give the IP address, let it be 10.0.0.1 is IP address, subnet mask, okay, because it is a class A IP address, default gateway 10.0.0. let it be 10. So this is the IP address, we have to assign it for the excuse me. So we have to assign it for the router, okay, that means the gateway. Now, so okay, we completed this PC. So let me go to the router 0. So here we have to fix the IP address. This is fast Ethernet 0 by 0. Okay, so let me go to the router, config fast Ethernet 0 by 0. So the IP address is 10.0.0.10, subnet mask 255.0.0.0 and make port status on. So we completed this 10 network. Now let me go to the 50 network. So I'll complete this, then we can go for the other networks. So here let me go to the PC1, desktop IP configuration. So here the IP address is, so let me have 50.0.0.1, subnet mask 255.0.0.0. So default gateway is 50.0.0.10. Okay, so this is the IP address, we have to assign it for the router. Now I am going to the router, this is fast Ethernet 0 by 0. So let me go to the config fast Ethernet 0 by 0. So the IP address is 50.0.0.10 is IP address, subnet mask 255.0.0.0, make the port status on. So these two networks we completed, that means network 10 and 50 we have completed. So let me go to the next, okay, we'll go to the 20 network now. Now, so let us assign the IP address for the 20 network first. Here you have to know the name of the interface. So this is serial 2 by 0 with clock rate, and this is 3 by 0, okay, serial 3 by 0. So now let me go to the router. So I am going to 2 by 0, serial 2 by 0. So the IP address here it is, this is a 20 network, so we can take 20.1, 20.0.0.1 is IP address, subnet mask, then clock rate is 64,000. I am going to make the default clock rate 64,000, port status on. So this is 2 by 0 with clock rate. So the other end, this is 3 by 0, serial 3 by 0, but no need to have clock rate here. So let me go to the router, serial 3 by 0. So the IP address here is 20.0.0.2 is IP address, subnet mask 255.0.0.0. So you can just make the port status on. So we completed the 20 network. Now let me go to the 30 network. So if you see the name of the interface, this is serial 3 by 0 and this is 2 by 0. So 3 by 0 is the clock rate. Now let me go to the router. I am going to 3 by 0 IP address. So this is 30 network, I think, yeah, 30 network. So we can have 30.0.0.1 IP address, subnet mask, and you can fix the clock rate. So the default clock rate I am going to take 64,000 and make port status on. So the other end, this is 2 by 0. So let me go to the interface, serial 2 by 0. So here the IP address, okay, so this is a 30 network. So let me give 30.2. 30.0.0.2 is IP address, subnet mask, and then make port set is on. So 30 network is also ready. So let me go for the next network, which is the 40 network. So if you see the name of the interface, this is serial 3 by 0 and this is serial 2 by 0. Okay, so 3 by 0 is the clock rate. Now let me go to the serial 3 by 0 IP address. This is a 40 network. Okay, so I'm going to use IP address 40.0.0.1, subnet mask 255.0.0.0, and this is having the clock rate. So let me give the clock rate. Default clock rate 64,000. Make port state is on. So I'm going to the next one, the other end, and this is serial 2 by 0. So let me go to serial 2 by 0 IP address. So IP address, this is 40.0.0.2. okay, is IP address, subnet mask, then make port state is on. So we assign the IP address for all the interfaces. So IP address part is over. Now the next one is, if you ping now, okay, I want to test the connectivity from PC 0 to PC 1. So if you test the connectivity, so 100% sure it is not going to work, okay, because routing protocol is not enabled. Okay, so if you want to check it, we can just have a ping command. So go to the command prompt, ping. So the last one is 50.1. So 50.0.0.1 is the IP address. So if I ping, destination host unreachable. Okay, so you cannot reach, because so your packet is going to, okay, you are sending a packet, a ping packet, ICMP packet you are sending. So the packet is going to reach the router. So in the router it is asking, okay, I want to go to the 50 network. So my destination is a 50. So in that case, so automatically the router is going to search in the routing table. Only connected networks will be available. So there is no path or no route to the 50 network. So automatically you are getting the error message, destination host unreachable. Okay, now, so what we have to do now, we are going to enable the EIGRP protocol in this topology. Okay, now I am going for the router 0. Let me go to the CLI, command line interface. Now I am in the global configuration mode, config, okay, that means the global configuration mode. So I want to enable the EIGRP now. So what is the command means? The command is router. Okay, so if you have any doubt, you can use the question mark also. Okay, to get the help, you can see EIGRP is the option available. So EIGRP. So router EIGRP, I am giving a question mark again. Then autonomous system number. So you have to enter a number here from 1 to 65,535. So any number you can select. Okay, for example, I am giving the number 10. Okay, what is this? What is this autonomous system number means? So autonomous system number is an ID, okay, for a group of routers which is going to be under a single administration or a single control. Okay, so that is called autonomous system. Now in this case, what we are going to do means, we are going to put all the 3 routers. Okay, all the 3 routers I am going to put it under a single autonomous group. Okay, so that they can share the routing information. So I repeat, what is autonomous system means? A group of routers, okay, a group of routers, or we can say a collection of routers which is going to be under a single, okay, administration or single policy, okay, whatever the word you can fill it. So in this case, all the 3 routers we are going to have in a single group, okay, single autonomous group. If you change the group, okay, they will not communicate. So now I am taking the autonomous system number as 10. Okay, so the next one is network advertisements. So now what are the networks directly connected in this case means? So here 10 network is directly connected, 30 network is directly connected, and then for 20 network is directly connected. So 3 networks, okay, we have to mention here, we have to advertise. So network 10.0.0.0. So 10 network is directly connected, then 20 network and 30 network. So network 20.0.0.0, then network 30.0.0.0. So these are the 3 networks directly connected. So in this router. So almost EIGRP configuration is over here in the first router. Now let me go to the second router. Okay, so I am going for the router 1. here there are 3 networks directly connected. Okay, so 20, 40, 50. Now let me go to the router 1. So I want to go to the global configuration mode. Okay, I am in the global configuration mode now. So the same router EIGRP. So in this case we selected the autonomous system number as 10. Okay, so 10, the same number I am going to give here. Now, so here networks. So what are the networks directly connected means network 50.0.0.0, 50 network is directly connected here, then 40 and 20. So network 40.0.0.0, then network 20.0.0.0. Okay, so these are the 3 networks directly connected. So now you can see immediately they started communicating with the neighbors. Okay, because they are in the same group, so automatically the communication is established between these routers, between router 0 and router 1. Now, so let me go to the next router, router 2. So here I am going to enable the EIGRP. So let me go to the global configuration mode. So router EIGRP, okay, 10 is autonomous system. So same autonomous group, okay, because all the 3 routers it is going to be in the same group. Now, so here what are the networks directly connected means you can see 30, okay, 30 and 40, only 2 networks directly connected in this case. So 30 and 40. So let me advertise, okay, so network, yeah, it is 30 and 40. So 30.0.0.0, then spelling mistake, so network 30.0.0.0, then network 40, network 40.0.0.0. okay, so these are the networks. Now you can see immediately, so the EIGRP started communicating with the adjacency, that means with the neighbors. Okay, so configuration, almost the configuration is over. Okay, now you can give the ping command from the first PC, that means from PC 0 to PC 1, and you can see the reply. Then we can see the routing table also. So let me go to the PC 0. So I am going to the command prompt. So already we tried, okay, we gave the ping command from PC 0 to PC 1, but we got destination host unreachable. But now the same ping command I am going to give now. So you can see the reply now. Yes, so we are getting the reply. So first time we are not getting the reply because of the ARP resolution. So next we are getting the continuously we are getting the reply. So that means logical connection is available between PC 0 and PC 1. So your topology is working perfectly. There is no doubt in that. Now let us go to the routing table. Let us see the routing table of any router. Okay, so then we can learn so many things. So I am going to the router 0. Exit. I am in the privilege mode now. Show IP route. So there is a command. So this command is going to display the routing table. Now, if you see the routing table, so there are 1, 2, 3, 4, 5. There are 5 networks available. Okay, 5 networks available. So 10, 20, 30, 40, 50. So that means fully converged. Okay, so fully converged means, so router 0, that means the routing protocol EIGRP. So it learns about all the networks, okay, in the topology diagram. So it is completely fully converged now. Now if you see 10 and 20 are directly connected. Okay, so it starts with the letter C. So C means connected. So 10 network is directly connected, 20 network is directly connected, and also 30 network. Okay, so 30 network is also directly connected. So 3 networks directly connected in this case. Then the next 2 networks, if you see 40 and 50, they are learned. Okay, so the route is learned by using the EIGRP protocol D. So D stands for EIGRP here. You can see the code here. D is the EIGRP. So by using the EIGRP protocol, so the path or the route for the 40 network and 50 networks are learned. Now the next one you can see, if you take 40 network, for 40 network there are 2 paths available. Okay, there are 2 paths available here. So 40 network for 40. So this is the path 1, or we can say it is a route 1, and this is the route 2. There are 2 routes available. Okay, so that means the destination, this is the destination network. Okay, destination network, there are two different paths available, okay, for the 40. Okay, you see the topology diagram. So here I want to reach the 40 here. So if you want to reach the 40 from R0, router 0, so there are two paths available via this one. Okay, this is the first one and this is going to be the second path. So there are two paths available. So this is what we are seeing here. Okay, now the next one is 90. What is this 90? 90 means that is the administrative distance value of EIGRP routing protocol. If you take the RIP protocol, for the RIP protocol, the administrative distance value is 120, whereas here it is 90. So if the administrative distance value is less, that protocol is more reliable. Okay, it's a reliable protocol. So it's less. Okay, comparing with the RIP protocol, EIGRP is very less. So it is a more reliable than RIP protocol. Okay, so 90 is the administrative distance value. Then the next one is called metric. So this is the metric value of this route. Okay, so the metric value they are calculating here. Okay, this is the metric value and this is also the metric value for this route. Then via there is an IP address. So this is the IP address of the next hop, that means the next jump where you want to make that jump. So this is the next jump. Then the next one is, you can see the time. Okay, this is the how long this route has been learned, that means the age of the route. Okay, age of the route, and this will be if there is any change in the topology diagram in your topology, automatically the time is going to change, that means because of the update. So the next one is the exit interface. So this is called the exit interface. Okay, the same thing you can see, this is our target, that means the destination network, this is the administrative distance value and this is the metric, then this is the via, that means this is the that means the next hop. Okay, and this is the age of the route learned, and this is the exit interface. Okay, so these are all the things we are learning from this particular table. This is the routing table of first router. So you can go and see the next router. So in the next router also, okay, you can see the routing table. All the 5 networks will be available. Okay, 10, 20, 30, 40, 50. All the 5 networks will be available in all the routing tables. That means it is fully converged. So once if it is fully converged, you can move from any network to any network. Okay, you can send and receive the packets from any network to any network. Okay, so this is the concept of EIGRP. So the next very important thing that we have to know is, okay, EIGRP metric. So how this the cost or the metric is calculated here. Okay, if you see the RIP protocol, in RIP protocol, okay, it is hop count. It is a very simple calculation. So the number of routers that you are going to cross. Okay, so hop count is used there. But here in the EIGRP routing protocol, so the metric is entirely different. Okay, so you can see there is a formula available here. So what is the formula means 256 into K1 into BW, that means the bandwidth, plus K2 into BW, okay, divided by 256 minus load plus K3 into delay into K5 divided by reliability plus K4. So that means there are 5 different parameters will be used here. Okay, K1, K2, K3, K4 and K5. So we can say 4 parameters, not 5. So 5 different parameters will be used here. One is the bandwidth, load, delay and reliability. So these are the 4 different parameters will be used here for calculating the metric. Okay, the metric, or we can say the cost, we can say. So you can see this is the formula. The formula is given here bandwidth, load, delay and reliability. So by using this only, okay, the entire metric will be calculated. So I'm going to upload one more video soon. So for this calculations, how to calculate this with some examples. Okay, so we can see this later. So in this video, that means we are just configuring the EIGRP using the packet tracer. So our topology diagram here, it completely works. So there is no problem in that. Okay, and we also saw the routing table also. Okay, so this is about the EIGRP. About the EIGRP calculations, that means the metric calculations, we will do a separate video for that. So thank you very much. Keep watching.